Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Nazmi Abdul Razak, and I will present to you about our project, which is the energy assessment on Mosque, University of Technology, Petronas. So there is five of us, and my group members is Muhammad Aiman bin Ibrahim, Amir Imran bin Muhammad Sofian, me, Muhammad Azmi bin Abdul Razak, Muhammad Akmal bin Alias, and Ahmad Khairul Irfan bin Khalid. Thanks. So, for the introduction, so for our location of study, we have got Anonymous University of Technology Petronas, and so for this mosque, it consists of three main area, which is the main prayer hall, the women prayer hall, and also the outdoor prayer hall. This mosque can have a maximum occupancy of 8,000 people at a time, and for the average occupancy for five daily times of prayer, we assume it as 200 people. Uh, there is three importance of energy assessment. The first one is to monitor and control the amount usage of energy for daily, monthly, and also annually. And second one is to evaluate energy usage of the mosque and compare with mosques with similar conditions. So we will be comparing the energy usage of this mosque or its maximum and average occupancy, which is 8,000 people and 200 people. And the last one is to determine the feasibility of energy saving solution plan for the mosque. So we will have some energy saving plans, but we will determine whether it is feasible or not to be applied at the mosque. So for the building orientation, um, this mosque is located in Sri Iskandar Perak, and it has a latitude of 4 degree north and longitude of 101 degree east. So the position of this place is close to the equator on the Earth. Thus, no noticeable changes in the times of sunrise and sunset. Unlike the country that has four seasons, where we can observe sunrise and sunset have quite a big impact on their energy assessment. So from the picture shown, we can see that at 3 p.m. The northwest side of the mosque is receiving more the most daylight, the most sun daylight, so it is receiving solar heat radiation the most. So what makes it more terrible is the wall of the mosque uh, is made from single clear glass, so it can receive two. The first one is conduction from the sun, and the second one is solar heat radiation. So this is the building climate factor. So since the mosque is located in Sri Skandar, so we take the all the related information for this location, which is Sri Skandar. So we have the hottest month, which is in March, and the peak temperature of the day for the time is at 3 p.m. So we have a temperature range of 10 degrees Celsius, which ranging from 32 degrees Celsius until 22 degrees Celsius, and it have a relative humidity of 80%. So this is the building layout plan. So our building layout plans are obtained from PMMD UTP, and as I said before, there are the three main area of the mosque, which is the main hall area, women prayer hall, and also outdoor prayer area. So the main hall area is about 950 meters square. The women prayer hall is about 450 meters square, and outdoor prayer area is about 6,600 meters square. Uh,
Now, I will discuss about building envelope audit. Building envelope consists of those elements of a building that enclose conditioned space through which thermal energy may be transferred. It can be divided into three sections, which are building characteristic and construction, window and door characteristic, and also insulation status. For building characteristic and construction section, it can be divided into a few subsections. For building orientation, as mentioned by my friend previously, the front side of Masjid An-Nur is located in northwest direction, while the back side is at southeast direction, right side is northeast direction, and left side is southwest directions. This mosque also has two areas of cooling zones, which is indoor and outdoor praying area, including prayer hall for women. And for other characteristic, the floor was made by the marble floor tile, as you can see in the picture, concrete wall with a thickness of 15 cm, metal deck, flat roof, and concrete ceiling from level to level. Not to forget, the mezzanine floor style was applied, which is it is to connect the ground floor with the upper floor. For this section, it is more in discussing about building and window characteristic. The frame type used in An-Nur Mosque is horizontal fixed single glass window with aluminium frame. The glass was untinted and the perimeter for this window is different at the male prayer hall and woman prayer hall, where for the male is 4.14 meter squared for each window and 2.024 meter squared for each woman window. After the calculation based on the perimeter, the gross wall area would be 60%. As for now, there are no crack or broken panes happen in the mosque, and there's no weather stripping condition and skylight applied at the mosque. And for the daylight, solar radiation that can pass through the window is set to 4.62 kilowatt hour per meter squared day. And for the last part of building envelope audit is insulation status. The insulation status of mosques in Malaysia is particularly important due to the hot and humid tropical weather condition in the country. Insulation helps to reduce heat transfer through the building envelope, which can help to maintain comfortable indoor temperature and reduce the need for mechanical cooling. In An-Nur Mosque, the insulation was installed at the roof in order to reduce the heat gain, especially during the hot condition. The type of roof insulation that has been installed is reflective insulation. Reflective insulation be installed underneath the roof deck or on top of the insulation layer, with the reflective surface facing downward, as you can see in the picture here. Due to this, there are two advantages that can be get by installing the insulation, which are, the first one is it can reflect the radiant heat energy back towards the roof, and second is it can prevent heat from entering the conditioned space below.
For the building energy audit, we divided the building into several categories, which are inside area, which is the conditioned confined area, outside area, toilet and air handling unit, also fan coil handling unit. This is the table for detailed calculation of the building. The total daily power usage for each equipment is calculated in watt hour. Firstly, the left-hand side here shows the calculations of equipment that may contribute to energy consumption inside the conditioned area, which is categorized as area inside. Meanwhile, the left-hand side shows the equipment for outside area and also toilet. On this slide, on the left-hand side, it shows the energy consumption of various models of air handling unit and also fan coil unit that are used in the building. On the right-hand side here shows the total daily power consumption, which is 697.17 kilowatt hour. We also received the DPM for An-Nur Mosque from the person in charge of the mosque. We extracted the data for 2 months, January, February of 2023. There are consistent peak power consumption of around 1000 kilowatt hour every Friday due to Friday prayers. But the average daily power consumption is just around 895 kilowatt hour, as shown from the straight dotted line on the graph. To compare the average daily power consumption obtained from the DPM with the calculated daily power consumption, which is around 697 kilowatt hour, there is a percentage difference around 20%. This is because the non-uniform daily power usage of the building. This slide shows the calculation of current building energy index and also energy intensity. The building energy index is calculated by dividing the average daily energy consumption with gross floor area of the mosque. The result obtained is 67.83 kWh per meter cube per year. Meanwhile, The energy intensity is calculated by dividing the average daily energy consumption with the number of occupants in the mosque. The result obtained is 40.85 kWh per occupants per year if the mosque reached its maximum capacity, and 1,634.18 kWh per occupants per year if the average number of occupants is considered.
So moving on to the economic analysis. So for the first improvement, which is the improvement of the equipment efficiency, the total cost of a new electrical equipment for Mosque to replace the current equipment are represented in this table. So the equipment is categorized into three areas, which is either inside, outside, and the toilet or the wudu area. So the total cost to do this replacement is about 28,408 ringgit. So this table shows the revised total daily power usage for the mosque following the equipment replacement. According to the calculations made in the table, the total daily power consumption can be reduced up to 74.13 kilowatt. So the equipment replacement was intended to reduce the long-term power consumption by utilizing the high-efficiency electrical equipment such as the LED tube light, air cooler, and the dryer. So we can have a more efficient and environmentally greener system by doing the replacement. So by looking at the tariff, which is the green table, this would be the monthly bill for the current and new equipment calculated using the tariff by TNB. So the total saving of 800 ringgit can be observed for this first improvement. So as our next improvement, which is on the operating hours of the air conditioner, the current operating hours has a total of 10 hours. We aim to reduce the operating hours only to 8 hours. So this is due for every player. It does not take more than 1 hour. Therefore, reducing the operating hours is an alternative that can be implemented in enhancing the energy consumption for the Mosque. So we can observe that the total daily power consumption for now is 419 kilowatt hour. So this would be the revised operating hours where we reduce the 10 hours to 8 hours, and we can see the total daily power consumption is around 335.2 kilowatt hour. So by comparing the both table for the tariff, the total amount of saving that can be obtained by improving the operating hours are 1,435 ringgit per month and 17,220 ringgit per year. So for our last improvement, which is the improvement on the glass shading on the upper side window at the Al-Nur Mosque, as for now, only clear glass are used for the window that allows radiation of sunlight to enter the mosque without any shading. So therefore, by applying tinted to the window, we can reduce the sunlight radiation, hence reducing the cooling load. What we can observe here from this table is before the shading, we have a total of power consumption 3,600 for monthly, and by applying the new shading, we reduce the power consumption to 3,120 kilowatt hour. By using the formula Q radiation equal to solar heat gain factor times the cooling load factor times the shading coefficient times the window area, we can count the radiation. We can count the Q radiation for the saved one, which is can be converted into 2 kilowatt. So we can have a total saving of RM20 RM274 ringgit per month and 3,288 ringgit per year. So for the revised building energy index for average participants, we can see a reduction of 30 kilowatt hour per meter square per year, which is before is 52.81 kilowatt hour per meter square per year, and after we have the building energy index of 37.83 kilowatt hour per meter square per year. So for the revised energy intensity for average participants, we can see a reduction of 722.77 kilowatt hour per occupants per year.
Alright, so we'll move to the next part, which is the feasibility study and the payback period of the improvement. So this is the first improvement, which is the improvement on equipment efficiency. From previous section, we had upgraded certain equipment in order to increase energy savings. So I would like to explain about the feasibility of this improvement. The total cost from previous section is 28,400 ringgit, and the annual savings for this improvement is 9,636 ringgit. So in order to calculate the simple payback period, we will divide the cost and the annual savings. So we will get a value of 3 years of payback period. For discounted payback period, we will assume the discounted rate is 10%. So from the table in this slide, the payback period is 3.6 years. Moving on to the second improvement. The second improvement is the improvement on operating hours, or the air conditioning operating hours. So in this improvement, we would not have any cost, so there will be no payback period calculation. The monthly bills on the current operating air conditioning is 7,059 ringgit per month. And after we reduce the operating hours from 10 hours to 8 hours, the monthly bills reduce to become 5,620 ringgit. So we will subtract the value of the current and the new improvement and multiply by 12 months to get the annual savings. So we will get the annual savings of 17,225 ringgit. Right. So the last improvement is the improvement on the glass shading. The area of the window is 1,065 feet square, while the cost is Rm 3 ringgit 50 cents per feet square. So the total cost to tint the window is Rm 3,195 ringgit. So from previous sections, the annual savings we get is Rm 3,280 ringgit. The simple payback period calculation we get is 0.97 years, while for discounted payback period, you can refer to the table, is 1.07 years. So from all three improvements that I have explained previously, we believe that all of these improvements are feasible to be conducted since the payback period and the savings are quite better. Okay, we will move to the life expectancy of the improvement. Okay, this is the list of life expectancy for the new equipment that we buy for our improvement. The LED lamp is expected to be used up until 8 years, while the air cooler is expected to be used up until 6 years. And lastly, for the Dyson Airblade, which is the hand dryer, it is believed to be used up until 10 years. In our opinion, the life expectancy for all equipment is quite good, since all of these equipment's life surpass the payback period of the improvements. So I think that is all for this part.
So as a conclusion, conducting an energy audit and implementing an effective energy management is crucial for promoting efficient energy use. This is also aligned with SDG 12 that emphasizes the importance of utilizing the resources in a sustainable manner to minimize waste and reduce environmental impact. So for some further recommendations, the first recommendation is by installing motion sensors that aim to reduce energy wastage in the mosque. By using the motion sensors, the light can be automatically switched off when the area is unoccupied, which results in a significant energy savings. And our next recommendation is by integrating renewable energy sources, which is a solar to the power system. Solar panels can be used to power the lights, air conditioners, and other electrical appliances in the mosque. And our last recommendation is by doing a proper maintenance of the HVAC system, which can enhance the efficiency of the HVAC system itself. So I think that is all from us. Thank you.